Okay, so today we're going to start with page 205. We're going to go over the last section for this week, this semester, not week. We're going to start with system of linear equations. We're going to talk about system of linear equation. We're going to solve system of linear equations using different methods. So first, we're going to prepare for that using, so here we have three different scenarios. We have to answer those few questions. So the first question is you have equation only with x. The other one, see this equation have only x. This equation have x and y. And here we have a system of two equations with x and y. So it looks like the first one is the easier one, the next one is the kind of middle, and the last one looks like more complicated, right? So we're going to do the last one. So let's go over what is in common, what is different. How many solutions are possible for the first one? So how you solve the first one? We're going to solve the first one when you get x by itself. So we're going to, oops, sorry, I stop sharing my screen. So we're gonna solve it when you subtract 2 in both sides, minus 2 in both sides, and we're gonna get x equals 8, right? So this is how you solve it. So what is the solution? One number. How many solutions are possible? One solution, because it's a linear equation, right? How you graph this equation? X equals 8 is going to be just a point on the graph. X equals 8, that's the point on the graph at 8. Now, the second equation is have x and y. This is equation of line. And let's pick a solution. You can pick like when x is 0, y is going to be 5 because 0 plus 5 equals 5. So this is one solution. How many solutions are possible? So here we have many solutions. You can have as many, like you can have 1 and 4. You 5 and 0, right? So there are many, many solutions. So how many solutions are possible? I'm just going to put infinity number of solutions, right? And all the solutions belong to a straight line. So all the points on the straight line, they're also the solutions. So let's graph the line. So I'm going to graph like 2 or 3 points. So I have 0, 5. It's here. Then I have 1 and 4, 2 and 3, and just go all the way to 5, 0. And this is the straight line which continue both ways, continue forever. So the infinity number of solutions, right? So the graph is a straight line. Now looking at the last system of equations they give us, let's find one solution. So one solution could be a number which satisfies the first and the second. So let's say 2 and 3 probably, because 2 plus 3 is 5 and 2 times 2 is 5. I'm just picking numbers. 2 times 2 is 4. 4 minus 3 is 1. So one solution is 2 and 3. How many solutions are possible? When you graph them, you're going to find out how many solutions are possible. Now, this is how you find out the solution of a system of equations. So system of equation means you have two straight lines. So if those two straight lines are parallel, there is no solution. How many are possible? You can have no solution, and this is the symbol for no solution, empty set. You can have one solution, or you can have also infinity solutions if the two straight lines are the same line. So these are the three possible cases. Depends what type of equations they give us. Make sense so far? So now let's graph it. So see how this looks like. So we're graphing I'm gonna move it just a little up. So let's graph x plus y equals 5, and I already have that graph, so it's going through 5 and negative 5 in both sides. And then we're gonna connect them. Oops, and you're gonna get, oh, sorry, I messed up. So we're gonna connect those two, and it's gonna be a straight line. Now, when I graph the other line, I need 2 points for those lines. One of them is 2, 3. 2, 3. And let's pick when I replace x with 1, 2 minus 1. So 1 and 1 is also a solution. Everybody understand how I'm getting these lines? So those two lines, they cross each other in one point, and that point has coordinates 2 and 3. So this is actually the solution of this system of equation, because when you solve system of equation, you can have no solutions if they're parallel lines, because you have two lines here. So the case when you have no solution, you're gonna have two parallel lines. So two parallel lines never gonna cross each other. That's why you have no solution. If the two lines are in one point, that's your solution, and the solution is x, comma, y. So the solution is a point which has coordinate x and y. Now, is when you have the same lines, so the two lines are on top of each other. You have that case, we have infinite number of solutions, because any point from both of the lines is a solution for the system of equations. Make sense? You guys understanding this? Any questions? Okay, going to the next one. And here we have to match the equivalent equations. So let's see which one are equivalent. X plus y equals 6. Which one looks like x plus y equals c? This one, when I divide this one, when I simplify this divided by 3, I'm gonna get exactly the first one. So this is B. Everybody see that? The other one is 3x minus 4y equals 1. And should be this one, the last one, because if I multiply both sides by 2, I'm gonna get exactly this one. So this is D. Do you guys see it, or you want me to work it out? Do you understand why these are the same? Yes, okay, Morgan, understand. Do you guys understand how we get this? We multiply by 2. So when I multiply by 2 here, when I multiply by 2, that gives me 4. When I multiply this by 2, cancel the 2, and it's going to be 1. Okay, everybody see that? So when I multiply 2, it's going to cancel the denominators, and you're going to get exactly the one we have in number, the first one here, the second one. Then we have negative y equals 3x minus 9. So this looks exactly like C, but opposite sign. So if I multiply C by negative 1, I'm going to change the sign. So it's going to be negative y, positive 3, because negative times negative is positive 3, and then negative 9. And the last one is going to be A. Let's see why I say y equals. So here what they did, they moved the 12x over. So you add in 12x in both sides. And you have 6y equals 12x minus 42. And also you can divide by 6. So when I divide by 6, 6 divided by 6 is y. 12 divided by 6 is 2x, and then minus 7. So that's how we get the one here in the bottom. Okay, so that's how you match them. You have to be able to move it from side to side, multiply the equation by number, or divide by number. Okay. The next one we're going to actually do the steps. Multiply each of the equation by the given constant, and we're going to write what is the result. These are the steps you're going to need when you solve system of equations. You're going to multiply one equation by something, and then you're going to solve it that way. So here they give me the equation, you're going to multiply by 7. So multiply each term by 7. So it's going to be 21x minus 2 times 7 is 14y equals 7 times 8 is 56, right? So that's what you're going to get. So always when you multiply by number, both sides, make sure you multiply everything by that number, both sides. Now here multiplying by 3, so it's going to be 2 times 3, 6x, and also don't forget the x's and the y's, okay? Minus. Multiply by 3, 1/3 times 3 is 1, y equals 3 times 9 is 27. Then the next one is a little tricky because you're multiplying by -5. So that means you're also going to change the sign. So 4/5 multiplied by negative is going to be negative. 5 and 5 cancel, so it's going to be 4x. And then -2 times -5, it's plus 10 equals, and it's going to be positive 40. Okay, so make sure when you multiply both sides by something, multiply everywhere. And especially when you multiply by negative, it's a little tricky. The next one, you're multiplying by 2. So here we have fraction, which is not going to cancel, but still you can multiply by 2. So it's going to be -6/7x. So multiply by 2 means multiply only the top by 2. And then that's equals to -2y. Divide by 2 both sides, which means each of those be divided by 2. I'm freezing, I'm sorry. Oh. Okay, so we have, when you divide by 2, 2 and 2 cancel, and you're gonna write it y equals 3/2x plus 4, and just leave it like that. Okay, the next one, number 10, we're gonna divide both sides by -3. And when you divide by -3, just do it like this, divide each term by -3 because it's easier to simplify after that. And you're gonna get y equals -x. Now -9 and divided by -3 is gonna be +3. Okay, so that's how you do it. And then I'm gonna do one more, like let's say number 14, you're gonna divide by -1, obviously, everything. Now let's do number 11. Number 11, you have to get y by itself. So first you have to subtract 2x, move the 2x over, and then divide. So you're gonna get 3y equals 15 minus 2x, doesn't matter which one is first, and divide both sides by 3. So you're gonna get y equals 5 minus 2/3 x. Okay, so that's how you do 11. Now let's do one like that, like 12. You want to get y by itself, so always the steps are move the x over, minus 3x, and then divide by the number in front of y. That's always the steps. So I have -3y equals 9 minus 3x, and divide by -3. So we're going to get y equals 3 plus, I'm sorry, negative 3 plus 1x, just x. Or you can write it like x minus 3, doesn't matter which one is first. Okay, let's do one with fraction. Let's do, which one? 15, 16, or 17? Let's pick one of those. Which one you want to do? 15, 16, or 17? 16. Okay, let's do 16. So 16, we're going to solve for y. So again, I'm going to, now here you can do two ways. You can multiply by 5 and cancel all the denominators. You can do that first. And that way you don't have fractions anymore. So I'm going to multiply both sides by 5. So 4/5 times 5 is going to be 4x minus 5y equals 50. And then from here, you solve it the way you solve in anything else. Subtract 4x. And then divide by negative 5. So have negative 5y equals negative 4x plus 50. And then you're going to divide by negative 5. And then we're going to get y equals, I'm going to write it here, y equals 4/5. You can reduce that, x. And then minus 10. Okay, so that's how you do those, that's how you solve for y. Then we're going to skip this. We're going to do this later. We're going to start with system of linear equations. And this is pretty much what we just did. So I'm not going to do this again. Point graph in a straight line. I'm not going to do that. System of linear equation is a set of 2 or more linear equations. This is how the system of linear equation looks like. And then the solution of system of linear equation is a number pair. I told you we have solution of system. It's a pair x and y, like coordinates of point, which makes both equations true statements. Okay, so the equations have to be true. So here we have, they give me 4 and negative 2 is a solution. So you plug it in the first equation, you plug it in the second, and both of those are true. Okay, we did something like that. And let's do this example here. Actually, this is just, they just give you the graph. Okay, they give you the graph of the two equations. We did something like that also. And the point where they intercept, that's the solution. Okay, and here you have the facts, which we already talked about it. The fact we talk about this. We have exactly one solution, no solution, or infinity many solutions, and these are the different cases. So one solution is when they cross each other in one point, and this is the solution which have coordinates x and y. The point where they cross each other, it's the solution. If you have two parallel lines, you have no solution. And if they're the same line, then you have infinite number solutions. Okay, we talk about these three cases, right? And then here we're gonna review matrices also, because one of the methods of solving is by elimination. So how you solve by elimination? So here we have this system to solve. X minus equals -1, negative x plus 3y equals 3. So this is the given system. So you're gonna use elimination, and this is the elimination method. It's really easy. So you're gonna eliminate x or y. So you're gonna focus on the x's, or you're gonna focus on the y's. In this case, x's are ready to go. What that means? when I add the two equations, x minus x is gonna cancel out. So they're gonna eliminate the x, and we're gonna have equation with y left. Okay. So this is how you do it. So when I add those two, these cancel, and you have negative 2y plus 1y is y equals 2. And that's my one number, y equals 2, right? We already know y is 2. And then after you get y is 2, you plug it back into the other equation to find the x. Because I have x minus 2 times 2, 1. Right? So this is negative 4. I'm going to add 4 in both sides. And that's how we get x equals 3. Everybody see that? So this is the elimination method. Okay? Everybody understand how we eliminate? So now in this case, it's easy to see that x, and when I add the equations, x and x is going to cancel. But sometimes it's not that obvious. And we're going to make them the same with opposite sign. So here we have augmented matrices. And matrix is a rectangular, like a table, where you just get the coefficients. So here we have, if you have this system of equations, and you're gonna get the numbers in front of, see, these are the numbers in front of x, these are the numbers in front of y, and these are the numbers in the other side of the equation. So you have 1 in front of x and negative 1 in front of x, right? Negative 2 and 3 in front of y, negative 1 and 3 in the other side. So you have coefficient matrix, these are the coefficients in front of x and y, and constant matrix is what they're equals to, okay? And so these two matrices, when you put them together, they make augmented matrix. And the augmented matrix pretty much have all the numbers from the system, okay? And then the method to solve it is you eliminate, when you add them, eliminate, and they're just operations we're doing to solve them, okay? I don't know if you're gonna go to matrices, you'll see. The number of row and the number of column are called dimension of the matrix. So here we have the size of the matrix is m times n. So the size is m by n, like here. This is how you see the size. And the matrix, when you have the same dimension, same row, same columns, it's called square matrix. So here you have examples. You have one matrix have dimension 2 by 3. That means 2 rows and 3 columns. So you have 1, 2 rows, and you have, so the first number is always representing the row, and the second number always represents the column. So you have 1, 2, 3 columns. Everybody see that? The second matrix is like a table, like Excel table. You have a 2 by 2 because 2 rows, 2 columns. The next one is 3 by 3, okay? And the last two, there's a square because they have the same row, the same column. And here you have more example of matrices. We have column matrix, which is only one column, and 4 rows. So 4 by 1 is column matrix, and row matrix, you have only one row, which is the dimension is 1 by 5, 1 row and 5 columns, 5 elements in that row, technically. Now, the position of elements, so every number in this matrix have position, and this is how you write it. A with the little indexes A, J, I, and J. For example, A1, 2 means the first row and the first column. Oh, I'm sorry, this is 1, 2, not 1, 1. So A1, 2 means element which is in the first row and in the second column. See, first row and second column. And that's the number there, -3. That's why it's equal to -3. Everybody see that? Now the next one, A1, 2, is going to be first row, and second column is going to be the number -2. That's how you do it, okay? So here we have, the goal is to, now why you need to use matrices? Because when you put it in the argumented matrix, the system in the argumented matrix, the computers can solve this really easier because it's just numbers and just can solve it. So what you're going to do first, you're going to write the argumented matrix for the system. And this is how you do it. You're going to have, like here you have, let's do the try it. So how you do the matrix? You're going to start with the coefficients in front of x. So the first one is -1. The second equation have 0 x's, right? So I'm going to put 0. You have to put number there. And then the numbers in front of y are 8 and 3. Then you're going to put the vertical line, which represent the equal sign. And then what you have in the other side, you have the numbers of 27 and 12. So that's how you get the argumented matrix. Okay, nothing else. Really easy, right? Any questions so far? Okay, so now actually we're going to start solving a system of equations. And this is how you solve them. So first they're going to give me, the first one, we have to check if this is a solution. 7,2, so they give me 0.72. And they're asking, is that point is a solution for the system? So this is how you check it. You plug it in. X is 7 and y is 2 in both of the equations. So the first one, x is 7 minus y is 2 equals 5. So plug it in. So what you have, 7 minus 2 is 5. 5 equals 5, which is good, right? It's right. Now let's check it in the second equation. So the second equation, I'm replacing x with 7. So I have 2 times x is 7 plus y is 2. That should be equal 1. So what you have here, 2 times 7, 14, plus 2 is not equal 1, right? So this is not true. So the answer here is no, because, why is no? Because the second equation is not satisfied with these two numbers, right? That's it. And then after that, we're gonna actually solve the system. So let's solve this system of equations. So we're gonna solve it by the two methods from algebraic approaches. Elimination or substitution. So I'm gonna show elimination because elimination is easier. And this is how you solve elimination. We're gonna add the two equations. We're gonna cancel x or y. Okay. So how you do that? I'm gonna focus on the x. So let's start with 1. We're gonna focus on x or y. How you pick which one to start with? Usually I start with the one with opposite sign, because when I multiply by to make them one negative, one positive, you know, multiplying by negative, it's always a little tricky, right? So that's why I start with positive and negative. So I'm going to focus on the y first. I'm going to cancel. I'm going to eliminate y. And why I'm doing that? Because I have positive and negative. And how I'm going to make them cancel each other. Now, if I have the same numbers, 5 and -5, when I add them, it's going to be 0. So that's why I have to multiply the first equation by 5, everything by 5, and then that's going to cancel the y. So I'm going to do that. I'm going to multiply the first equation by 5. So that gives me 10x minus 5y equals 5 times 0 is 0. But you still multiply both sides, right? And then I'm going to copy the second equation, 3x plus 5y equals 39. And now when I add those two equations, 5y minus 5y is 0. They cancel out. So what I have left with 13x equals 0 plus 39 is 39. And then I'm going to divide both sides by 13 to get x by itself. See, when you eliminate y, you're going to find x. So what is x equals? X equals 3. So after I find x, I need to plug it back in the other equation. One of the equation, doesn't matter which one. and I'm going to find the x. I'm going to find the y, sorry, y. Now, you can plug it in one of those. Doesn't matter where you plug it in. Make sure you plug it for x. Another way to solve it, if you cancel the x now, if I eliminate x, I'm going to find y. But if you get a whole number, it's easier if you plug x equals 3 in one of those equations. So I'm going to plug it in the first equation. So I'm going to have 2 times 3 minus y equals 0. So 2 times 3 is 6. 6 minus what is 0? 6, right? I'm going to add y in both sides. And I'm going to get 6 equals y. Y equals 6. So these are my answers. Now, when you write your answer, make sure you write it like that. X is in the first place, so it's going to be 3, comma, y is in the second place, always. And put it as a pair, like a coordinates of point. So always when you solve, make sure you write your answer like this, coordinates, okay? Any questions about elimination? Any questions? Okay, let's do one more. So let's solve number, let's do number 2. So for number 2, I'm gonna start with, I'm gonna eliminate y again because I have plus and minus. So now, in this case, I have 2 and 5. So that means now, if one of those is factor of the other, you can multiply by something and make them the same. In this case, we need to multiply both of the equations by something. So in this case, I'm going to multiply the first equation by 5 and the second equation by 2, because that way I'm going to make 10y and negative 10y. Okay? So in this case, you're going to multiply both equations by number, which is okay, but make sure you multiply both sides of the equations, and then you're going to cancel the y. So this is what you have. 5 times 3 is what? 15x. Then plus 10y equals 5 times 3, 15. And then you're going to multiply the second equation by 2. So you have 2 times 4 is 8x minus 10y equals negative 19 times 2 is what? 38. And then you're going to add those two, this cancel, and you're going to have what you have here. 15 plus 18 is 23x equals negative, what is that? We have negative, so it's going to be just subtracting 38 minus 15 is going to be 23, negative 23. And then divided both sides by 23 is going to give me x equals negative 1. Okay, so I have x equals negative 1. And then I'm going to plug it in one of the equations, doesn't matter. I'm going to put it in the first equation again. I'm going to have 3 times negative 1 plus 2y equals 3. So this is negative 3, so I need to add 3 in both sides to move it over. So we get 2y equals 6. Divide by 2. So get y equals 3. And then let's write the solution. The solution is going to be a pair. X in the first place, which is negative 1, comma 3. So this is my answer. Everybody understand how to do that? Okay, let's do a few more, and then I'll get you, I'll put you in group to practice this. Let's do one of the, or let's do both of those. We can do it both. So we're going to do number 3. Okay, so here we're gonna, both of those are negative and positive, right? So it doesn't matter which one you're gonna cancel. So let's start with x this time. So I'm gonna cancel the x. So I'm gonna look at the x's. Both of those are positive and negative, opposite signs, so we're good. So here we have C2, 2, it's a factor of 6. So that means I'm gonna multiply the first equation by 3, is gonna give me 6. So, and the second is negative 6, so they're gonna cancel when I do that. So 3 times 2 is 6x minus 3y equals 3 times 5 is 15. And I'm going to copy the second one, minus 6x plus 3y equals 7. And now I'm going to add those equations. So x cancel the way we expected it. Now, what's happened here? Y also cancel. So what is left? There's no x, there's no y. So if something like that happened, you need to see what is left, because this is the case when x and y cancel. If both of those cancel, these are the cases when you have no solution or infinity number solutions. Depends what is left. So you have to see what is left. So what is left here? Nothing left in the left side. So that means you're going to put 0. And in the right side, we have 15 plus 7 is 22, right? So you have 0 equals 22. Is that true statement? Is 0 equals 22? No, this is not true statement. That means this is the case when you have no solution. And that's okay, because the system have no solution. Okay, and that's what you're gonna write. Just write no solution and you're done. Okay, so when x and y cancel, you have to see what is left. If you get 0 equals 0, which is true, then you're gonna have infinite number solution. Make sense? Okay, so here we have the, let's do number 4. So for number 4, we have fractions. And what I'm gonna do, I'm gonna cancel the fractions first. So I'm gonna multiply the first equation by 3 to cancel the denominator. And I'm gonna multiply the second by 6, because the denominators are 2 and 3. So if I multiply by 6, I'm gonna cancel all of those. So when I do that, I'm gonna get 9x plus y equals 9, because 3 and 3 cancel, so I have 1y. And then the other one is going to be 3x minus, because 6 divided by 2 is 3, 6 divided by 3 is 2y equals negative 6. And then which one you want to cancel? Obviously, we're going to start with the y, because you have plus and minus, it's easier that way. So I'll multiply the first equation by 2. So that will give me 2 times 9, 18x plus 2y equals 2 times 9, 18. And then I'm going to copy the second one, 3x minus 2y equals negative 6. And when I add those, y cancel, so I have 21x equals 12, right? And then I'm going to divide by 21. And the answer is going to be a fraction. So you can reduce, can you reduce that? You can divide by 3. So it's going to be 4 over 7. So that's my x. And then you can plug it in one of the equations. And in this case, you have to work with fractions to solve it. Or another way is if you multiply, you know what, let's do that. We're going to multiply the second from here. We're going to continue from here. I'm going to cancel the x now. So when I cancel x, I'm going to get y. So in this case, I'm multiplying the second equation by negative 3, because 9 and negative 3 is going to cancel. So you have copy the first one and multiply the second equation by negative 3. So that's negative 9x plus 2 times 3, 6y equals positive 3 times 6, 18. And then x cancel, and you have 7y equals 27, right? Divide by 7. 27 and 7 doesn't cancel, so this is my y, 27/7. Okay? And the solution, you're gonna write the solution as a pair, of course. You have to be in that specific order. So the first number is x. I'm gonna squeeze it over here. X is 4/7. And y is 27/7. So this is my answer. So always remember, when you get fraction, if one of the answer is fraction, it's easier if you go ahead and eliminate the other variable. Because if you plug it in with fraction, it's a little longer to simplify. Because you have to work with fractions and solve the equation of fraction. It's a little bit more. I mean, it's still doable, but it's easier if you do it that way. Okay? So now, let's do one word problem. So pick one from 5, 6, 7, 8. Just one. I'm going to do one. 5, 6, 7, 8. Just one. Let's do 5 then, if nobody want to pick. So I'm going to do 5. So animal shelter has 1 of 5 cats and dogs. And they have 15 more dogs than cats. How many dogs do they have? How many cats? So we have, let's say we have cats are X, the dogs are Y. So the total is 105, right? So the first equation is going to be X plus Y equals 105, right? And then they have 15 more dogs. Okay? So what that means, when I subtract the dogs minus the cats, it's going to be 15, right? Because the dogs are 15 more. So it's going to be X minus Y equals 15. Everybody understand that? Because there are 15 more dogs. Hold on. It's backwards, sorry. It's Y minus X, right? Because the dogs are more. So Y minus X is going to be 15. Yes? I just put it in that order. Why? Because the dogs are more. Why? When you take away the cats, they're going to be 15 more left. Okay? So this is actually how it is. And this is what you need to solve. This is the system we have to solve. It's ready to add, right? So I can add them, X cancel. So I have 2Y equals, what is that? 120, right? Going to divide by 2. And that's going to be 60 dogs, right? That's Y. And then how many are the cats? You can subtract from 105 or plug it into the first equation, minus 60. 45 cats, right? So that's how you solve it. You always, when you have to solve word problem, you have to set up 2 equations and solve it as a system. Okay? So that's how you do number 5. Now, let's go ahead and continue with the matrices. So matrices, we're going to just do some basics things. We're going to find the size, the dimension of these matrices. We're going to write this, from the system, we're going to write the argumented matrix. From the argumented matrix, you're going to write the system. And then also we're going to find the solution if you have given this system of equations. This matrix is given. So let's do that questions. So first, how you find the dimension of a matrix? So this one, you're just gonna, the dimension is always, the size is always row by column. Okay, always row by column. So the first one, A, how many rows? There are 3 rows by how many columns? 2 columns, right? Can you tell me the dimension for the second one? It's the same actually. B is 3 by 2. And how about C? How many rows? 2 and 3 columns, right? Now, how about D? We have how many rows? 1, 2 rows by 1 column. Okay, that's it. Let me ask you something. Let's look at the matrix A. And can you tell me what is the element 2, 2? The element 2, 2 is in second row and second column. What is the element? What is the number there? Can you tell me? In the matrix A, what is element 2, 2? That's right. Good job. It's a 0. Good job. Okay. Now let's write, the next one is let's write the system. So the system is given, let's write the argumentative matrix. So what you're doing, you're just getting the numbers and write it as a matrix. So the numbers in front of X are 5 and 1. The numbers in front of Y are -4 and -2. Then you put the line, the vertical line for the equals, and then the numbers are 9 and -3. So this is the argumentative matrix. You can put it in the computer and you can solve that in different methods. Okay, let's do the next one. We have system with three equations. So you're going to do the same. The numbers in front of X, they're going to be 3, 1, and -1. The next column is the numbers in front of Y. So it's going to be -2, 2, and 4. And the next one is the numbers in front of Z. So you have -3, 3, and -6. Always look at the numbers, goes with the sign in front. Then you have the equals, the vertical line, and then the numbers in the other side are -5, -3, and -1. And that's it. Now the next one here we have to write the system of linear equations, and you're going to use the variable X, Y, and Z. So they give me the argumentative matrix, you have to work it backwards. So these are the numbers in front of X, in front of Y, in front of Z, and then the equals in the other side. So this is how it's going to look like. You have 3X minus 2Y, you write it row by row here, plus 4Z equals 6. So that's how you get the first equation. Then you go ahead to the second row and you do the same, you get the second equation. So you have 9X plus 4Y minus 1Z, you can just put Z, doesn't matter, equals 0. And then the last row is going to give me the last equation. We have 6X minus 8Y minus 3Z equals 3. And that's my system. Okay? That's the system of equations. And then the last question we have for today and for this semester is we have used the given matrix to write the solution of the corresponding linear system. So how are you going to do that? You're going to change this system to this matrix to a system. So we're going to write the numbers in front of X, the number in front of Y. So we have 1X plus 0Y, there's no Y, equals -7. And there is no X, so 0X, 1Y equals 4. So looking at this system, can you tell me what is the solution? Obviously, yes, X is going to be -7 and Y is going to be 4. That's your solution. So the goal is when you have argumentative matrix to make it in this form where you have 1 and 1 in diagonal. Okay, so this is what we have for today.